I'm going to do line 6 and 7 off my sample project. Okay, so here is line 6. Okay, there are my endpoints. Okay, so I can see my endpoints are -6, -1, and 2, 11. Okay, so now I'm going to go ahead and use my slope formula to calculate the slope. Okay, and remember my slope formula is, and I'll just put it up here. It's y2 minus y1 over x2 minus x1. Okay, so here we go. Y2, and my little thing is a little formatted off, but womp. Okay, so y2 is 11 minus y1 is -1. Okay, and then my x2, this is my x2, minus x1. All right, let's do the math here. This becomes a plus sign, double negative, that's 12. This becomes a plus sign, and that is 8. Okay, and then I notice actually 12 over 8 can be reduced because I realize, oh, both of these numbers can actually be divided by 4. And so this actually becomes 3 over 2. Okay, so my slope, and you should always reduce, it just makes, it's going to make your life easier. It's also just like, correct to reduce. Okay, so my slope is 3 over 2. Okay, now here's what I'm going to look. I'm going to check for 2 things. I got a positive 3 over 2. So I'm going to look at this graph and I'm going to say, is this slope positive? And I say, oh yeah, yep, from left to right, this goes uphill. Yep, it does. Now, I need to check, is the number correct? Did I count correctly? So I'm going to find a point on the graph, and it doesn't matter which one, like I could find this point, and I'm going to count up 3 over 2 and make sure that I got my slope correct. So if I go 1, 2, 3 over 2, yeah, look, I landed on the line. Like 1, 2, 3 over 2, I landed on the line. So my slope is in fact 3 over 2. Okay, so looks good. So my slope is correct. Now, this says use the slope in one of the endpoints to find the equation of the line. Show work. Now, I want to point out to you that you actually have enough information to write the equation of the line. I'm going to do it. I'm going to show the work because that's the requirement. But I actually have enough information because remember when I'm writing the equation, it's y equals mx plus b. So I have my m, my slope, y equals 3/2 x. And if I actually look at this line, I can see what the y-intercept is. You see it? It's right there. It's positive 8. Okay, so look, I'm going to kind of cheat. I'm going to write this. Okay, my y-intercept is that 0.08 on the graph, right? And it is. That's what it looks like on the graph. Now, I'm going to do the work, and I'm going to get 8 as the y-intercept. But I want to point out that I actually already know it. Now, this is different. Like, see, look, when I do line 7 next, I won't know it because, look, it doesn't touch the y-axis, right? But this one I can see. So it's kind of nice to just sort of know in advance. But I do need to show the work because that's the requirement for the project. So I'm going to use the slope, which is 3 over 2. And I'm going to use one of the endpoints. Okay, I can choose either one. I'm going to just go ahead and choose the positive numbers because why not? Okay, so what I'm going to do is I'm going to use this x and this y and this m, and I'm going to plug in to y equals mx plus b. So I'm going to plug in y equals m times x plus b. And I'm going to solve for b right now. So first I'm doing 3/2 times 2. So I'm going to do this multiplication, and I'm just going to take it out over here. So 3/2 times 2, 2 is the same as 2 over 1. So 3 times 2 is 6 over 2. 6 divided by 2 is 3. So 3 over 2 times 2 is 3. And I want b by itself, so I'm going to subtract 3 from both sides. And notice I do get I get my b, my y-intercept as 8, and there we go. I have enough information, right? The y-intercept goes here, the slope came from right here, and there's my equation. Okay. Now, the domain. So again, I can look at the graph, okay, and I can see that my x values go from here, right? I'm looking at just this line, line 6, and so if I were to draw my left and right, it would be here and here, so that'd be -6 to 2, which is my domain. I can also actually look here and see like, oh, see my x values? It ends at -6 on the left and it ends at 2 on the right. And so I can write it like this. -6 is less than or equal to x is less than or equal to 2. Okay. And then for my range, I can actually, again, I can use these points. I can see like, oh, this is my bottom value. and this is my top value. And I can look on the graph and I'll get the same answer, right? Here's my line, this line right here. And so the bottom is here and the top is here. So the bottom is at -1 and the top is at 11. And again, I could have just gotten that right here. So this is -1 is less than or equal to, y is less than or equal to 11, right? And you can see like its bottom value is less than or equal to y is less than the top value. And then once you actually go ahead and graph it in Desmos, you can check this box. This is just like kind of to help you out so you don't lose track of which ones you've graphed already. So once I go ahead and graph this in Desmos, I'm going to check that box so that way I just don't lose track. But when I do go to graph it in Desmos, this is what I'll type. I'll type y equals 3/2 x plus 8, right, the equation of the line. And then what I'll do is I'll limit the domain, right? This is the domain and range. I could actually, like, this would work too if I typed this, but it's more typical to say, you know what, I'm going to say I want to cut this line on the left and right. And this is what you would type in Desmos. All right, let's look at line 7. Line 7 has something a little bit tricky that happens with it, and you're going to see in a sec. But let's grab the endpoints first. So the endpoints are here. So that's 211. And here, right, this is the line, 914. So 211 and 914. Okay, I'm going to find my slope, which is y2 minus y1 over x2 minus x1. And what I get is 3/7. Okay, so my slope is 3/7. And let's go ahead, does the sign match the graph? Well, I got positive 3/7. Yes, this is a positive slope, looks good. Does the rise over run count the graph? So let's start here and count up 3. 1, 2, 3/7. 1, 2, 3, 4, 5, 6, 7. Yep, it sure does. So it looks like 3/7 is my slope. Okay, now that's going to do something a little bit tricky right now when I go to plug this in, and you'll see. So I'm going to use 3/7. I'm going to just go ahead and use my first point, which happens to be the same point, right? Because that's where line 6 and line 7 meet. Okay, but I want you to notice what's going to happen here, because if I were to continue this line, it actually doesn't hit the y-axis right directly at a whole number. So I'm going to end up with a y-intercept that's not a whole number. Okay, but it's not the end of the world. Let's just do the same thing we would always do. We can use a calculator if we need to. Okay, so I'm going to plug in y equals m times x plus b. Okay, so I'm going to do this multiplication, and here's where I'm going to end up with a fraction, right? This is 3/7 times 2/1. 3 times 2 is 6/7. Now here's the thing. That is a fraction. That does not reduce. It does not become a whole number. It looks like this. Okay, but I'm still going to do the same thing, which is I still need b by itself, so I'm going to go ahead and subtract 6/7 from both sides. Okay, and I get b equals. Now, ideally, you would do this math, and you'd realize that this is a number less than 1, right? Like 7/7. 7/7 would be 1. So this is a number that's a little less than 1. So what I'm going to end up with here is 10 and 1/7. Okay. Ideally, you'd be able to see that and say like, oh, well, if I'm going to take one of these holes and take 6/7 of them, I'm going to end up with 1/7 left plus the other 10 holes. But here's the thing. If you're like freaking out, you could do this. This is 6 divided by 7, right? That's how you type it. You could do this. 11 minus 6/7. And you'd get 10.14. Okay. Now, is that perfect? No, it's not. But if you were to graph this in Desmos and you were to type, so like here, right here's like the perfect answer. Here's the slope plus 10 and 1/7. Now this is perfect because this is an exact number. This decimal is not going to be exact because what's going to happen is you're going to round it, right? You're going to have to like cut it off. But if you were to write in Desmos y equals 3/7 x plus 10.14, you would be fine. It would be okay. Okay, your graph would look just fine. So feel free to lean on the calculator if you need to. But here, my y-intercept is 10 and 1/7. Is it the same y-intercept as the graph, right? Now here, and what I might do is even go get a ruler, right? But if you kind of were to do this and continue the line, what you would see is it hits just above 10, right? Just above 10. So that's about right? 10.14, 10 and 1/7, just above 10. That is just about perfect. Looks good. Okay. Now my domain, that's my left to right value. I'm just going to look up here, right? I see that it starts at 2 and ends at 9. That looks like this, right? I can see it on the graph that it starts at 2 and ends at 9. Those are x values. Okay, I can also see it in my points. And then the y values, this graph goes from a bottom of 11 to a top of 14. Okay, again, I can see it here in my points, and I can see it here that it goes from 11 up until 14. All right, and there we go. Once I graph it in Desmos, I'll check my box and I'll be good to go.